is that multiverse? Well, we gave you a little hint just now, but let's continue here. We have this is what it looks like. This is what they imagine. A bunch of balls, a bunch of balloons. Okay. And the big question here, that you're going to have to answer is, what's the black stuff that separates all these balls? What's inside each ball? Okay. Now, this is not really a correct uh, vision of that, because this is how they visualize our universe, or at least our visible universe. They say it looks more or less like this. This is what they mapped out there. Okay, okay, and if you put this in the right context, you have to put it also in terms of the Big Bang, which looks more or less like this. Okay, you have the Big Bang, the history of our universe, and when you take a snapshot of the last one, right? What you're really doing is taking a cross section of time, a cross section of motion, which is location. All you have is every atom it was separate from all others at a given distance from everything else. So they're all just separated by a little by distance. And so what you have is that last sheet. And you got to think of it as a two-dimensional thing because it's a cross section, right? It's a three-dimensional photograph of God, right? But everything's standing still. So it's God's movie. It's a three-dimensional frame. Each frame is three-dimensional in God's movie, in this universal movie. Okay, so this is what you got to think about as far as the universe. Each universe has its history, and so maybe this is what the multiverse looks like, really. All these W maps, okay, one at a given distance from another. And again, the question is, what separates them, okay? If we were to put it in the universal movie, right, standing still, because they don't have to be moving, we can take a snapshot there, you see it. It occupies a single frame, okay? And remember, that frame is three-dimensional, okay? So that means that you're using God's camera, okay? You took a snapshot of the universe, every atom, wherever it is, and if you take that whole thing and you say there's another universe, fine, no problem. But then the question is, what's the black stuff that separates every one of these? Okay, that's the big question. If especially when each one of those universes includes space, okay? Because well, you have here. Let's go with the questions here. Here's the question, okay? Definition of universe. You need to first define what a universe is if you're going to talk about the multiverse. So you got to start with the universe. And these two so-called mathematical physicists, mathematicians, they didn't define the word nothing to begin with. They should have started with the definition of nothing, then they can talk about nothing. But no, they started at something and they worked their way towards nothing, saying, let's take things out of the box and we'll end up with nothing. And they say, well, you can't take everything out of the box. And so they said, well, there can't be any nothing in the end. That was their conclusion. But they never defined what nothing is, okay? We still don't know what it is. And so the first question is, what is a universe? And are there other universes out there? Okay? If so, what separates one universe from the other? And then, is there any object, anything that can isolate two universes? Okay, that's the question. And more specifically, can you separate? Can you put a fence to space? Can you put a fence around space and say, okay, space stops here, and we don't know it continues? We don't even have to worry too much about that. The question: can you put a fence around it and say this is the end of space? Okay, because if you can't do that, that means that other bit of matter is sharing the same space as our universe, meaning, is it a different universe? If universe is space and matter. Okay, that's the issue. Okay, so let's begin with a definition. Well, we tried last week. They put in there, these are the definitions you'll find out there, and they put energy in there, they put time, they put everything they can think of, even your experiences, they call that part of the universe, okay? And so, energy, time, every continent, planet, stars, galaxy, obviously, right? Matter and space. They put everything in there, and they say universe is everything, even what you do. In other words, the history, the motions, not only the present, but everything in the past is also part of the universe. And a lot of people include, almost everyone out there includes also the future. So we don't have a good definition of what the universe is, and it's very hard to talk about the multi-universe, multi-universe, if we do not know what universe is, what it means, what the word means. What does the universe mean? And so what they tell you is usually what the universe is comprised of. The universe, he says, okay, anyways, we have all these people that we covered last week, people like Stephen Hawking, and he said that this was his notion of the universe. He says the universe is space-time, and space-time is an event. All the points that make up space-time, and every point is an event, means something that happens at every point. And if you take the sum of the aggregate of that, you end up with what space-time is. And so you have to think of this as all these dots in motion, because each dot is an event. And so I guess this is the best picture we can concoct from what good old Stephen told us. Okay, I'm not sure what sense any of that makes from what came out of his mouth, because he's saying that a dot, a point, which is just an object, right? Static object. You would put it in the Universal movie. You would put it in a single frame, and he says it's happening. It's something that occurs. So he's putting a verb in there, and he's representing it with a dot. So who knows what all that means, okay, from a physical point of view. And then you have here another version, which is the gravity waves that we covered last week. And yeah, what you see is, what are those waves? I mean, what are those things? And they say, what's energy? Well, what is energy? Energy is a concept, a mathematical concept. What's that got to do with physics? What are we staring at? What have they illustrated? Okay, so that's the question there. And so, yeah, you can illustrate anything you want and say energy. Well, show me energy. Bring it to the conference. Put it on the table so we know what energy is before you move it. I need to see a picture of energy. I need to see a mock-up, something standing still. Then you can move it later on. And of course, you can't do that with energy, because energy is a mathematical concept. But see, that's what they're doing here. They're showing you all these vibrations. They say it's energy. It's the waves. Wave is not a physical object. Wave is a verb. What is waving? See, you got to stop it first and take a snapshot of it and say, this is what is waving. This is energy. This is a field. And you can't do that with any of them, okay? Because all these words are already in motion. They embody motion. Okay? And here you have the famous dark matter, okay, and dark energy, of which the universe is made. So the real matter, the one we can see, the luminous matter, is just a very small percentage. Non-luminous matter is about 3.6%, and the rest is all dark matter, dark energy, and just in case, they put in their black hole and wormholes. They have all this stuff in there, and they say this is what the universe is comprised of. So we have all these versions, because we have, if the universe is made of dark matter, dark energy, right? A lot of it, 90%, right? 90+%. Then, and it's all invisible, right? And intangible, obviously. So it gives the mathematicians, or the astronomers at least, a lot job security. They have a long time to find something that doesn't exist out there, right? So they can do a lot of work for nothing, right? But the question is, if our universe is made up of all this stuff, then what is waving? What are the waves? When they say there's a gravity wave coming through the universe, and what are we talking about? Are we, what is that dark matter that's vibrating? Is it dark energy that's vibrating? And what is dark matter? What is dark energy? Well, they say, well, we don't know what it is, and they fix it with that, saying we don't know, we're just looking for it. and then you have, how do you put that together with Hawking's points? So we have these points, that all of the universe is made of points, right? That's a little different than what the dark matter, dark energy world says, and that's different than what the people who say waves are, and fields and energy. So we have like these three camps, and it's like you can't reconcile one with the other. That's the problem. Okay, so I don't know. These are some of the things that we got to look at. Okay, and so here we have, again, this is the question we need to answer. We need to answer, what's the dark stuff that separates all these universes, especially when the dark stuff is inside each one of those universes? Because otherwise you're saying, that space, that dark stuff, is not inside each one of those universes? You see the problem? That's where the problem is. So you cannot say that space is outside and serving as a cocoon, as a shell for the universe, because space is inside the universe as well. That means that that universe is sharing the same space that this other universe is sharing. If they're all sharing the same space, because you can't put a fence on space, then what the hell is this multi-universe? How can you say that there is another universe if they're sharing the same space? If universe is matter and space, aside from all the other stuff that the mathematicians put in there. Okay, this is the issue. Okay, and here we have it. This is what these other two folks went through, and they said, look, in the end, there's no such thing as nothing. And so, the question is, if we have nothing out there, how do you put a fence around nothing? How do you prevent someone from crossing from nothing into whatever, into thought? Because it can't be into something. It's got to be into something else that is not nothing or something. And so, again, we're at a loss to understand, first, the definition of the word universe, and second, to find out what separates each one of these universes. That's where we're headed. So how do we do it in science? Well, in science, physics, right, branch of science, we start with the foundations of physics. And foundations means you're going to define your terms. Okay, you're going to define them scientifically. What is a scientific definition? Well, you see one there. It says limitation placed on the extent or usage of a word. Okay, that's what a scientific definition is about. You should be able to use it consistently, rationally, scientifically. Okay? And the first two words you want to really define is something and nothing. What is something? That which has shape. What is nothing? That which doesn't have shape. See how easy it was? So we have these two words are antonyms, okay? And we have synonyms there for something. We have object, thing, anything, body, there's several. And for nothing, we have a couple there: space, vacuum, nothingness, void. Okay, so we have synonyms. You can't use those to define the word nothing. You have to define nothing, and nothing is that which doesn't have shape. Okay, very simple. One has shape, the other one doesn't. They're antonyms. Now we can use them consistently, rationally, scientifically. And there we have some other words: concept, okay, distance, location, exist, and motion. Word exist is very important because physics is the science of existence. Physics tries to elucidate or try to explain, right, by making assumptions of what exists. Okay? And what is existence? Physical presence. In other words, an object that has location. Okay, so that's where we start. That's our starting point. And once we have the definitions in place, now we can use them to speak and to make ourselves understood. People can understand because they have relatively simple definitions. Few words. The fewer the words, the more crisp your definition, the less the devil's advocate can destroy from your definition. So always make your definitions as short as possible. And they never learn that anyways. You look at all the definitions of mathematics, science, what is physics. Oh, they have paragraphs. Any little piece that you can take out, you just destroyed their definition. Okay? Life, words like life, they cannot define, obviously, because they have all these words. It takes a paragraph to define the word life. Okay, so here we have the Universal movie. And where are we going to put universe? Well, we said that last week. We said it's just matter in space. Okay, so all those little dots, they could be galaxies. Galaxies have stars and planets and so on, but every one of those is made of atoms. In the end, everything is atoms. Okay, so all we have is matter and space. Okay, that's our universe. Okay, and people say, where's energy? Well, energy is a little weird. Here, we'll show you energy for the first time in your life. If you've never seen energy, here it is. Drummer, okay, here it goes. There we have it. Mathematical physics says that everything is discrete particles just moving around. Whether it's space-time or quantum mechanics, even string theory, it's all made of particles ultimately. Rope hypothesis, there's a single thread in the entire universe. Okay? That's all there is, just one thread. Okay? See how simple it is and how different it is. Okay, so you don't have to believe in it. We're just asking you to accept the assumption because this is what we're going to use to explain everything from gravity to electromagnetism, including magnetism and electricity and functioning of the atom. Okay, okay, so that's our starting point. Here's what this produces. In the case of quantum, all you have is discrete particles. In the case of the rope model, well, we have that all atoms are physically connected. They're all interconnected, okay? And so we have essentially hydrogen atoms. That's what we're going to look at. Just about everything in the universe is 90%, you would say, is hydrogen atoms. Maybe around close to 10% is helium. So that's the universe in a nutshell. And the 1% is maybe all the rest of the matter that's out there. But what we're saying is all hydrogen atoms are interconnected, okay? And they're connected by that thread that you just saw. And that thread turns into every atom, which turns into a rope that connects DNA-like rope that connects any two atoms, which continues to another atom, and so on and so forth. So the thread itself is the one that converts from atoms to rope, from rope to atom, and so on down the line eternally. The whole universe is just that. That's how simple our universe is. Okay? And then what you have, higher elements are simply more hydrogen atoms bunched together. That's all it is. Together with neutrons, which is another issue. Okay? Okay, so we end up with our interconnected universe. It looks something like that. Okay? So this would be our universe. And you can see the black stuff there, that's called space or nothing. And yeah, we have to put a frame around it just because I have to put, stop it at some point. Is space infinite? And the answer is no. Only objects can be infinite. Nothing cannot be infinite. Okay? The word infinite came from mathematics. And so they said, hey, we can count forever, and that means that the universe is forever, or space is forever, or whatever. The way we look at it in physics, we don't use math. We just say, look, space is nothing. It has no shape. That means that, matter is finite at some point. And, you can go to the last bit of matter in the universe, but you cannot go to the edge of space because space has no edges, no borders, no surface. Okay? Space is the opposite of what mathematics uses for space, which is, a ball. They always say it's a ball, and they tell you, well, we don't know what's outside the ball, what's giving shape to the ball, because we've never been there and we can't be there, so it's an unscientific question. No, this is a question of physics, not of philosophy. It's a question of physics. You have to tell us what surrounds space if you're going to give space a form, a shape. And because you turned it into an object. You turned it into a thing. You turned it into something instead of nothing. So yeah, we have a problem with that. Because space is nothing, no shape. It has no surface, no perimeter, whatever. And it's the opposite of an object which has shape. Period. We're done. Okay, that's how simple it is. So we don't have to worry about what's outside of space giving it shape because space has no shape. And it's very hard for people to, put their brains around that. Okay. Okay, so let's find out what happens if we try to leave our universe. What if you wanted to travel to the last bit of matter? Okay, that's what we're going to be doing now to see if we can get to another universe. Okay, because this is about the multiverse, right? Okay, so here's our universe. Okay, this is our starting point. Okay, and let's say you wanted to travel outside the Earth. Okay, and the first thing outside the universe, but before that, you have to consider the fact that our universe is all interconnected. All the atoms, according to the rope model, all atoms are connected. Okay. Now, I didn't draw all the connections there. Okay. So some people are going to say, hey, Bill, where are the gazillions of connections? No. I didn't draw all the connections. Just imagine that every atom is connected. That's what I'm trying to illustrate there. Okay. And now, let's say we put God into the picture. God created the universe. Okay. So let's put God in there. Okay. And so the question is, does God exist? And there are different ways of answering this question. So, what did we say exist was? Well, it was an object that has location. Well, it looks like God has location, at least with respect to the universe here, right? I think it's straightforward. But as you can see, God is not connected to our universe. Let's connect them. And we're just going to connect one atom of God. We're going to assume God is a physical object. He's made out of atoms, and he exists. Why? Because he has distance with respect to every atom in our universe, and he's connected by ropes. Okay, but the question is, if the ropes weren't there, okay, if we have this situation again, right? Does he exist? And that's a question of definitions, and I think that if we are going to define the word exist as an object that has location, we can still say there's distance between God and the universe, therefore God exists by definition. Because we do not need the ropes in order for God to exist. We just need distance. We need location, which is the set of distances. And in this case, every atom in God's body has distance with respect to every atom in the universe. But you can see what would happen if God is really connected to our universe, right? If we all share the same single thread, well, the farther he goes, the more skewed our universe becomes. He's pulling all those threads from our universe. So, that would really have an effect on us if he was able to do that, right? So keep that in mind as well. The farther God goes, the more thread he pulls out from our universe. And this has something to do with, us traveling outside of our universe under the rope model. You're going to be pulling ropes the farther you go. And the farther you go, the more skewed that whole picture is going to look. Here's the universe out there, little ball that you can see, bird's eye, you can see it far away, and you're out there in the middle of nowhere, close to no matter, right? Because you're leaving the universe, you just left the last bit of matter out behind you. So you're kind of stretching those ropes more and more and more the farther you go. And so are you drawing all that rope from the thread of the universe? Yes, of course. That's what you would be doing if you attempted that, right? If you could achieve it, right? Okay, so here we have our universe again, okay? And here we're going to try to leave the universe, okay? Here we go. Give me a second here. Here you go. Okay, you're going to try to leave the universe. Okay, take your spaceship, and you can see what's happening to the ropes. You're pulling those from the universe, okay, the farther you go. Of course, this is not the scale to your ship is not that big, hopefully, but you can see what I'm trying to illustrate here. You're leaving with your spaceship, but you're connected to every atom in our universe. And so there, you finally are in the middle of space, let's say. Right? Maybe you're still traveling, but we'll just say that you just stood still in space. We took a snapshot of you. Okay, this is where you're at now. Okay. What happens if there is another universe and you're going in its direction or somewhere? Okay, so here's the two universes now. Okay, we have two universes, and we're going to have our spaceship again. Okay, you're going to leave the Earth. I'm sorry, our universe. Okay, and you're going to head outwards. And the question is, here you have another universe. So now you have a different situation because you could be in the first case you had gravity only behind you, but now you can have gravity in front of you because gravity is the number of ropes, right? That are the closer you get to our universe, the more the ropes fan out, and the more gravity you will feel. And here you're running in the opposite direction, so you have less and less gravity as you move out. But now you have a universe in front of you that could be tugging on you, but when? Here you are in between the two universes, right? And the question is if there are two situations. One is that you could have this situation where that universe, every rope in that universe, every atom in that universe is connected also to our universe. Therefore, it's also connected to every atom in your spaceship. Okay, that's one possibility. Okay, and we have a different scenario here. Here you have, these two universes are isolated from each other. That means that, all the ropes in our universe are connected among them, and the ropes in the other one are connected among them, but none of those ropes are connected to any other the atoms in our universe. So you have this other universe which might be bigger. Maybe if it's bigger and none of the ropes are connected to our universe, it could be that, for example, light has a different speed because our universe, the speed of light has to do with the thread and the number of atoms out there, in the universe. If we have more rope, more thread in that other universe, could it be that light travels faster or slower or whatever? We don't know that, but that's something you got to think about. But the question is, you have these two situations. One is where the two universes are isolated, and here the two universes are connected. Well, if they're connected, I don't even think we can talk about two universes because, first of all, they both share the same space. And in this case, they share the same ropes, the energy, right, that the mathematicians talk about. Those are the ropes, and we have torsions moving along the ropes. That's why we can see Andromeda or anything for that matter. And so we would be able to see this other universe because every atom there is connected to our eye, to the atoms in our eye. But in this case, we would not be able to see that other universe because none of the ropes of that universe are connected to our eyes. So that universe, as big as it is invisible to us. We can't see it because we can only see through the ropes. Torsions along the ropes is light and, also gravity for that matter. But the point here is we would not be able to see that universe in this situation. And it would not have any gravitational effect over us because, as you can see, gravity has to do with the ropes, and there are no ropes of that universe connected to our spaceship. Okay, so it creates different scenarios, okay, that you have to ponder under the rope model when you talk about the multiverse. This is one, and here is the second one there. Okay, those are the two scenarios. But you can see that in either case, they're sharing the same space. And what is universe? Universe is matter in space. So we have a situation where we need a new definition. We can't talk about the word universe because the universe is everything. And meaning space and matter, and the ropes in this case, energy if you want to use the word energy. Okay, we're talking about the ropes, we're talking about the atoms, we're talking about the fact that space, right? So we have two chunks or clumps of matter. And maybe that's what we have to call them. We can't call them universe because universe is everything that includes space. Here they're sharing the same space. We can't put a fence on space. So there's only one universe. There's only one universe. There can't be any multiverse. There could be different clumps of matter. And if there are two different clumps of matter, the question there is whether they're connected or not. Whether the two universes are connected, the atoms of the two universes are connected or not. If they're connected, it's like what we see today, it's our universe. But if they're not connected, then you can talk about two clumps of matter, not two universes, but two clumps. Whatever you want to call them. I call them clumps. You can use that word if you want. Say that Bill Gaede created. Okay? So we have two clumps of matter and not universes, because when we use the universe in that context, we are misleading, people. They say, oh, there's many universes. No, there's only one universe because we all share the same space. We cannot put a fence on space. So we all share the same space. There can only be one universe. There could be different clumps, and the clumps include, planets, gases, stars, galaxies, the whole works. Okay, so that's the way you got to look at it. Okay, one fellow asked a question in relation to that, and so I wanted to answer him. It says, if by physical existence we mean has location and shape, and the answer is you already failed. See, people put words into my definitions, and they want to change some of the words. That means they didn't understand squat. Okay, they're not paying attention. They think, well, it's the same thing. Like one guy changed and says, what is an object? Says that he didn't like the word shape, so he put the word surface. No, it's not surface. It's shape. Okay, it's not surface. Surface is a 3D concept. Shape applies to both 2D and 3D, and objects are both 2D and 3D. So you cannot use the word surface to define the word object. But people are not careful enough with their definitions, and they think, well, it looks the same to me, And so it's not shape. Okay, the word is object, thing. Okay, something. Okay, you can use those. So exist is object, thing, anything, everything, something, right? Plus location. Okay, we got that? Don't change the word object. Don't put the word shape in there and say, well, I'll rephrase it. No, don't rephrase anything. Every letter has to be right in the right place there. Okay, it's when you change something that you get into trouble because you think you said the same thing and you haven't. Okay, shape is an adjective. Let me repeat that. Shape is an adjective for the purposes of physics. Okay, it's a property of an object. There is no object that stands alone called shape. Okay, shape is a property of an object. And so you cannot say the shape did this, the shape did that. No, the object did this, did that. Shape is a property of the object. Okay, so if it's a property, it's called an adjective in physics. In ordinary speech, something else. They speak irrational language. Here we speak only rational language. Okay, shape is a concept known as an adjective, and location is specific to this rope connection. Okay, if there were two separate rope loops, then they never interact. Okay, so I guess he's talking about like, two universes where, the ropes are not connected from that universe to our universe. Any atom there is connected to any of ours. That's what he's saying. So the question is whether they interact, whether they can go through each other. Well, again, this is speculation. We can all speculate. You can speculate in both ways. The best way of doing it is making an assumption. And that's what we do. We make an assumption in one case where they do cross each other, and the other where they don't. And they say, well, what happens in one case, what happens in the other case? Because that answers his next question or his next concern. He says, it would make sense to ask how these rope loops are located relative to each other as they have no rope connections between them. And again, a lot of wording, but make it simple. This is the issue here is if the atoms of one universe are not connected to the atoms of another universe, can the ropes cross each other? You can make an assumption both ways and then explain something with that assumption. And likewise, if the two universes cross each other, one goes right through the other, we can't see them if they're not connected, right? Because we can't see that which is not connected to our eye, right, through the ropes. So the question is, would an atom of that universe crash against an atom of our universe? Would these two universes collide? Would the stars of each universe collide? I would think so, but again, that's a question of assumption. I mean, you're taking all this to a point where you're speculating a lot, and there's no problem with speculating, doing thought experiments, but then the only issue here is you make an assumption. You say, let us assume that they do collide, or let us assume that they go right through each other. You can make whatever assumption you want in these cases because you're doing a thought experiment in which you're maybe trying to explain something, or just having fun trying to find out what would be the consequences. Fine, that's all it is. Okay, but we're more concerned about what's in our world, and that's why we use the rope model to explain things that happen, in our everyday lives, like electricity and magnetism, gravity, and so on.